Kia ora, I'm slowly working my way through the Pure 3 exam that I wrote. Here are questions 1 and 2. So one of them is from back in 2013 and one is from way back in 2003, before you guys were all born. These were pretty straightforward questions and they were quite well done, although there were quite a lot of you who, as usual, forgot about the existence of the factor theorem. Right? So the factor theorem is one of those things that is just going to make your life better in every way. So please remember it. Okay, question 1, we've got a polynomial, we've got an unknown constant a. This is the polynomial, and we're told that x plus 2 is a factor of f of x. So we have to first find the value of a, and then we have to show that this equation has just got one real root. So that should be screaming at you discriminant straight away. Okay, so off we go. We've got f of x is equal to x cubed plus ax squared minus ax plus 14. There's no need for you to rewrite that. I'm doing that so that I can see what I'm doing. And we know that f of negative 2 has to equal 0. So we can substitute in negative 2. We get negative 8 plus 4a plus 2a plus 14, and that equals 0 by the factor theorem. So cleaning that up gives me what? 6 plus 6a is equal to 0, giving me a is equal to negative 1. So that means that my polynomial is f of x is equal to x cubed minus, not minus ax squared anymore. So minus x squared plus x, is that right? Plus 14. I just want to check that I've done that right. Right, let's see. Yeah, it is minus ax in here, right? So because it's minus ax, it becomes plus x because a is negative 1. I'm doing this without my work solutions in front of me. I'm just kind of doing it cold as you would do it. Right, now we're going to do some matching. We know that x plus 2 is one of the roots, so we know that we have to match up the rest. So we're going to have x squared in here, and we're going to have a plus 7 at the end here, and we're going to have some x term in here. So matching, what do I get? Well, I'll match on the negative x squared. So negative x squared is equal to 2x squared plus kx squared. So negative 1 is equal to 2 plus k, giving me k is equal to negative 3. And that means that now we can look at x squared minus 3x plus 7. So that is f of x. So I don't need to go as far through as finding the two complex factors here. I just need to show that there's only one real factor, right? And we know that that's the real factor. So we're going to show that this has got no real factors. So for x squared minus 3x plus 7, we have b squared minus 4ac is equal to 9 minus 4 times 1 times 7, which is negative 19. Negative 19 is less than 0, so it has no real roots. Therefore, f of x has only x equals negative 2 as its real root. Okay, so only one real root. So there you go. That's that first question done. Now let's see what's next. Yep, so that's worth 5 marks. Just be careful that you've actually answered the question, and you do need to do a little bit of explaining what you've done, right? So something to say discriminant negative, therefore no real roots, and then the whole thing has only got one real root. Okay, on to question 2. So I quite like this because it was just a nice combination of implicit differentiation and using that with a bit of coordinate geometry. So first up, we've got x to the power of a half plus y to the power of a half is equal to a to the power of a half. We have to get dy by dx in terms of x and y. So this is going to use implicit. We're going to have half x to the negative a half plus a half y to the negative half is equal to, what am I doing? Sorry, let's just start again. I'm not thinking. Oh, okay, so now I'm going to differentiate everything with respect to x. Right, so I've got half x to the negative a half, which is fine, because I can differentiate x with respect to, I can differentiate this term with respect to x. But this one I have to differentiate with respect to y, and then use the chain rule as usual, right? So we're just doing basic implicit differentiation. No product rule, no nothing else. This is a constant, so it has a derivative with respect to x of 0. Right, cleaning all of this up gives me the following. Now, it's not a show that question, though, so I think it's fine to times both sides through by 2. I'll go a little bit slowly. So we've got y to the negative a half dy by dx is equal to negative x to the negative a half. And at this stage, I think it's worth writing that as 1 over root y dy by dx is equal to negative 1 over root x. Okay, so dy by dx works out to be negative root y over root x, which I could write as this. It wasn't a show that question, okay, so it would have been fine. I think it's fine to leave it like that, but it just looks a little bit nicer like this. Now, the next thing we have to do is we've got a straight line with the equation y equals x, and that intersects the curve at point P. And we have to find the equation of the tangent to the curve at point P. Right, so at P, we have y is equal to x. So at point P, dy by dx is going to equal negative root x over x, which is equal to negative 1. So the tangent line will have equation y is equal to negative x plus c. So that's the first part done. Now we have to figure out what's this constant. So we're looking for the point P that intersects, so where the line and the curve intersect. Well, we know that we had root x plus root y is equal to root a. We know that y is equal to x, so that gives me root x plus root x is equal to root a. 2 root x is equal to root a. I can either square both sides now or I can do it later. So root x is equal to root a on 2. X is equal to a divided by 4. And that means that y is also equal to a divided by 4. So coming back to, where are we? What have I done? Right, so we know that our equation is going to be this. Y is equal to negative x plus c. And now we know that a on 4 is on that line. So substituting that in gives me c is equal to y plus x, which is equal to a on 4 plus a on 4, which is equal to a on 2. So my equation of the line, as usual, setting this out on a screen with a stylus has made it really, really messy, so I'm not very happy. We'll just put a wee line down there to fence that off. Let's get rid of the ruler. Okay, so my final equation is that y is equal to negative x plus a on 2. Right, obviously fine to write that in different ways. You could write it as 2y is equal to negative x, negative 2x plus a, and so on. But I think most people, and me, and I, did it like that. All right, I will keep on chugging through the questions, keep sending them in your requests for old exam ones as well. The next one that I'm going to do is probably the integration problem.